Hi everyone, and we're here today to talk about citizen science and how to use your Water Rangers kit to monitor water quality. You can use this in your classroom, you can use this outdoors, but we're going to introduce you to everything in it and show you how to use it. When you open your Water Rangers kit, you'll find all the tools you need to test a number of water quality parameters. This fits really well in the Ontario curriculum for students between grades 5 to 8. It hits links related to biodiversity, water systems, water quality, and the Pathway to Stewardship Landmark 22. It's really important to make sure that you record your data. So you're going to have a clipboard and a whole bunch of data sheets that you can use to record your data. And then when you're finished, you can submit it all to the Water Rangers website, and then your information will be included in the data set from people just like you collecting citizen science data from across Canada. We're going to walk you through how to measure a number of common water quality parameters today using your Water Rangers kit. You can also visit their website at waterrangers.ca and watch videos and learn more about citizen science and monitoring water quality. Your Water Rangers kit also has a book inside it, and on page 9 talks about all of the things you need to do to make sure you're collecting your water samples and all your activities safely. So make sure you do that before you head out. So your Water Rangers kit comes with 2 ways to test temperature. You have this thermometer, and you're going to use this to measure your air temperature. You're going to record that on your data sheet. You want to make sure it's not in the direct sunlight. It's got a carabiner so you can hang it from a tree, leave it there for just a few minutes, and then take a look and record what your air temperature is. You can also put this in one of your buckets and test to see what the temperature is.
You also have the conductivity and total dissolved solids meter. It also can record temperature.
This is a great way to check the accuracy of both of your instruments too, so we can test both ways and then compare. My temperature is 20 degrees. Candace, what's yours?
My bucket is 27.5 degrees.
By being a citizen scientist, it's kind of like being a detective. So you can start to detect changes or differences in your samples using these tools. Temperature can tell you a lot about a water body, and that could be a creek, a stream, a lake, or a river, because temperature influences the type of species that you're going to find there. In the Kawartha Lakes in the Peterborough area, we have lots of warm water fish, perch and bass or warm water fish. We also have fish that can only live in cold water. Trout are a great example of that. So just by looking at the species you find in a creek or a stream or a lake or a river, you can tell what the thermal regime, what the temperature is like of that particular location. Dissolved oxygen is also a really important factor and determines which species can live in certain areas. Dissolved oxygen is directly related to temperature, and so the colder the water, the lower the water temperature, the higher the dissolved oxygen, and vice versa. So species that live in warm water systems need less dissolved oxygen than species that live in cold water systems. So let's take a look at how we measure dissolved oxygen. Using the smaller vial that you're going to find in your Water Rangers kit, you are going to get a sample of water. Then we're going to open our test kit, and you're going to find a box like this. And inside, you're going to reach in, and there is going to be a set of glass vials. So you're going to open this really carefully, and we're just going to pull out one. So these are glass. So what I'm going to do is we're going to be breaking the tip. There's a little white line that shows you where it's going to break. So you're going to put it down inside your container. There are grooves inside the container to put the end right in. And then you're just going to push it really gently against the side of the container, and it's going to fill by itself. And then we're going to take it out, and we're going to flip it upside down twice. And you can watch that bubble going up. Now we're going to flip over our timer, and we're going to wait. So this is going to take 2 minutes. Now that we've waited our 2 minutes, let's take a look and see how much dissolved oxygen is in our water sample. So you are going to be comparing the color to see how many parts per million or milligrams per liter of dissolved oxygen you have. And it looks like we're coming in probably around a 9.
So we have this booklet here. It tells you how to interpret your findings and your results. So if you get a reading between 7 and 11 milligrams per liter, that means that the water could support cold water fish.
Every sample that you test is going to be different, and you'll start to learn all of the different species that you can find in your local water courses and where the best habitat for each one is. This is such a great way to engage your students. They'll be learning about chemistry, species diversity, and their local environment.
And now we are going to measure conductivity with our conductivity meter. So conductivity is a measure of the water's ability to conduct an electrical current in the water. So conductivity can be a clue as to what is happening in the water. If there's high conductivity or if there's low conductivity, it could infer that something else maybe is added to the water. And we're going to take a look now and test out these 2 buckets and see. So this reading is about 615. So that is a very high conductivity level. Now let's compare to our green bucket. All right, so this green bucket has a much lower conductivity than this purple bucket. Well, what can that tell us? Earlier, I put in some road salt in this purple bucket here. And so road salt can pass an electrical current. And that's why it has a higher conductivity level than this bucket here, which is just tap water. There are so many fun activities you can do with this Water Rangers kit, but the final one we are going to be displaying today is pH. And we are going to test this purple bucket for its pH. So it also reads alkalinity, hardness, and chlorine. So we put it in and we dip it in for 2 seconds, and then we dip it out, and we wait 20 seconds to compare it to our chart here. What's awesome about these test strips is that you're able to find out this information like the pH, alkalinity, hardness, and chlorine pretty much right away. And so you can see the chlorine there, it's at about 0. pH, 7.2, 7.5. Alkalinity, same thing, we want to compare here, and it's higher on the scale. And then we also got hardness. So hardness, the water's pretty hard here. It's closer to the lower levels. So what's awesome about pH as an indicator is that our pH water, we want it to be about 7 on the pH scale. That's where you want water to be at. So orange juice is very acidic, so it's going to be very low on the pH scale. Soda or pop, it's going to be very high on the pH scale. It's going to be very basic.
Data collection is a really important part of being a citizen scientist. There are a couple of tools in your Water Rangers kit, so don't forget to fill them out. You have the postcard version. On the back, you can put your name, the date, the weather, so we have records of what it was like the day you did your sampling. You also have the pad of paper here where you can provide some more details and actually track your data. Then you can add that on the waterrangers.ca website and have your data included with all of the other information collected from across Canada. You can visit our website at otonabieconservation.com to learn more about the Watershed Report Card and the programs and services that we offer. Thanks so much for joining us today.
See you next time, Pathway Explorers.